Edexcel, GCSE, Mathematics, Paper 1, Non-Calculator, Foundation Tier, June 2012. On the formula page, I would write down anything I think I might forget during the exam and that I'll find useful. So, as ever, I'm going to write down that the area of a triangle is the base times the height divided by 2. I'm also going to write down that the area of a circle is pi times the radius squared, that the circumference of a circle is pi times by the diameter, and I'm also going to write down that to work out the sum of the interior angles of any polygon, I need to do the number of sides, take away 2, multiplied by 180 degrees. And again, you would write down anything that you think you need to remember during the course of the exam. On question 1, I'm asked to write down the number marked by the arrow. So the first thing I need to do is check what my scale goes up in. Now I can see I'm going from 300 to 400, and it looks to me like I'm going to be going up in 10. So I'm going to check by going 310, 320, 330, 340, 350, 360, 370, 380, 390 and 400. So it is going up in tens, so my answer is 380. In part B, same again, I'm asked to write down the number marked by the arrow, and I can see I'm going from 6 to 7. So my answer is in between 6 and 7 somewhere. So this time I'm going to go up in decimals, so I'm going to try 0.1. So 6.1, 6.2, 6.3, 6.4, 6.5, 6.6, 6.7, 6.8, 6.9, 7. So it does work. So this arrow here is at 6.2. And finally, in part C, I'm asked to mark the number 34 on the number line with an arrow. And 30 is here, so it's somewhere after 30 in this area. And I'm going to see if my scale goes up in ones to start with. So 31, 32, 33, 34, 35. So it doesn't go up in 1, so the next number I'm going to try is 2. 32, 34, 36, 38, 40. So it does go up in 2s. And 34 was there on the number line. On question number 2, in part A, I'm asked to measure the length of the line AB and give my answer in centimetres. So I'm going to take my ruler and place it on the end of the line at A and work my way along to the end of the line at B, and I can see that that is 80 millimetres on this ruler, which would be 8 centimetres. In part B, I'm asked to measure the size of angle X. Now, before I start, I'm just going to write down that I know that that is 90 degrees and that is a right angle. And this therefore must be less than 90 degrees. So I'm going to place my protractor, lining up the crosshairs with the end of my angle. And as ever, I've got two sets of numbers on my protractor. I've got the numbers on the inside and the numbers on the outside. Now I need to decide which ones to use. Now I know my angle is going to be less than 90. So here I can see that if I read off from the outside, it's going to be 145, which isn't correct. So I'm going to be using the numbers on the inside. So starting at 0, 0, 10, 20, 30, and it's in between 30 and 40. So I'm going to come from 30 to the outside of my protractor, 31, 32, 33, 34, 35. So that angle would be 35 degrees. In part C, I'm asked to draw accurately a circle of radius 5 centimeters using the point C as the center of the circle. Now it's important that I use the cross at C as the center, not the actual letter C. So the first thing I need to do is take my ruler and my compass and open it out to 5 centimeters. And I'm going to do that by lining it up on a piece of paper and stretching it out until I get to 5 centimeters. So that there is 5 centimeters. I then take my compass and place the point at C. I'm making sure I'm only holding on to the top of the compass. I'm going to do an arc for one half of my circle, and then I'm going to swap hands and I'm going to do the arc for the second half of my circle. Notice it's one smooth line. I haven't had several goes at it. It's a nice smooth line and I've done it once. On question 3, I'm told that Helen carried out a survey to find out the fruit her friends like best, and I'm given the list here. Now the first thing I'm going to do is count how many items there are. So I've got 1, 2, 3, 4, 5 in the first row, and I have got 2, 3, 4 rows. So in total I've got 20 pieces of information. I'm now going to transfer that to the tally chart. So the first is apples. So I'm going to put a mark in the tally there. And I'm going to go through the list, adding marks and crossing off the information as I go through to make sure that I don't lose one. Now, this banana here is my 5th banana, and therefore when I come to the tally chart I'm going to cross that one off here, and I'm going to do the same here. I'm going to add a bar to the gate, and then I'm going to continue. Now when I do the next banana, I'm going to make sure I leave a little gap before I start the next group of 5. Now I'm going to turn those tallies into frequencies here. So I've got 4 in the apples, I've got 5 and another 2 in the banana, so that's 7 altogether, 4 in the oranges, 3 in the peaches and 2 in the pineapples, and then I'm going to add those up to make sure that I haven't lost any from my original list of 20. So 4 add 7 is 11, add 4 is 15, add 3 is 18, add 2 is 20, so I haven't lost any. In 3 part B, I'm asked to write down the number of Helen's friends who like bananas best, and I can read that from the table here, so that would be 7. In part C, I'm asked to draw a suitable chart or diagram to show the results above, and I'm just given a blank squared grid. So the first thing I'm going to do is I'm going to add on the vertical axis, which is going to be called frequency. And I can see that my frequency needs to go up to the maximum amount of 7. So if I start at 0, I can go 1, 2, 3, 4, 5, 6, 7, 8, and that should therefore fit all of the information from my table on. Now along the horizontal axis I need to have this column plotted, so I'm going to plot fruit along the horizontal axis, and then I need to add the information I'm given in the table, so apples and 4, to the squared grid. Now the first thing I'm going to do is I'm going to make sure that I leave in here a gap. So this first column needs to be a gap, and then I'm going to add a bar for the apples at 4. And obviously in your exam you would do this with a ruler. Here I'm just going to draw the bar like so. Now there's always a temptation to make this 2 wide or 3 wide. I'm going to keep it 1 wide just for simplicity, and therefore I know it will fit on. And then I'm going to leave another gap here, and I'm going to have a bar for bananas that is 7 high. And I'm going to carry on leaving gaps as I go along. Oranges would go to 4, another gap and peaches at 3, and another gap and pineapples at 2. Now don't worry about this empty space here, that's fine. As long as your bar chart's correct, you can have a gap here. And I'm going to make sure that I label this horizontal axis. So the first was apples, and then I had bananas, and then oranges, peaches, and pineapples. And to finish off, I'm going to make sure that I have drawn on, and again you would do this with a ruler, the horizontal and vertical axes. On question 4, I'm told that Daniel buys 1 loaf of bread costing £1.18, 1 tub of spread costing 94p, and 2 jars of strawberry jam. And he pays with a £5 note, and he gets 30p change. So first thing I'm going to do is work out how much money he spent. So he spent £1.18, 94p, which I'm going to write as 0.94 and line up the decimal points, and 2 jars of strawberry jam. I don't know how much the strawberry jam is, so I can't work that out now, so I'm just going to add these two up. And I'm going to get 8 add 4 is 12, 1 add 9 is 10, plus the 1 would make 11, so 1 carry the 10, and then 1 add 1 is 2. So I know so far he spent £2.12. He pays with a £5 note, and he got 30 pence change. So he paid with a £5 note, which is 5.00, and how much he spent must have been enough so that he ended up with 30 pence change. Well, from looking at that, I can see that he must have spent £4.70. Once I know he spent £4.70, I can say £2.12 of that is from the bread and the spread, so I'm going to do £4.70, take away £2.12. So I can't take away the 2 from the 0, so I'm going to borrow from the 7 and make that a 6, carry the 1, so 10 take away 2 is 8, 6 take away 1 is 5, the decimal point in, 4 take away 2 is 2. So there is £2.58 that must have been spent on 2 jars of jam. So what I need to do now is work out the cost of 1 jar of jam, so I'm going to do £2.58 divided by 2, and that will be my answer for the cost of 1 jar of jam. Now to do that, I'm going to do the bus stop, so 2's into 2 goes once, decimal point in, 2's into 5 goes twice, remainder 1, and 2's into 18 goes 9. So 1 jar of jam will be £1.29. Of course, you could have divided the £2.58 by 2 by taking the £2, dividing that by 2 and getting £1, and then taking the 58 pence, dividing that by 2 and getting 29 pence, and then adding the 2 together. But it's important that here we write my answer in terms of pounds. On question 5, I'm shown a coordinate grid and asked to write down in A part 1 the coordinates of the point A. So the point A, from the origin, I'm going to go along the corridor 1, 2, and then up the stairs 1, 2, 3. The coordinates of the point B in the second part of this question, I'm going to go along the corridor, but this time I'm going backwards, so 1, 2, 3, so -3, and I'm still going up the stairs, just 1 this time, -3, 1. In part B of this question, I'm asked to mark on the grid with across the point 3, -4. So starting at the origin again, I'm going to go along the corridor 3, 1, 2, 3, and this time -4, down the stairs 4, 1, 2, 3, 4. That would be the point C. I've marked it with a cross, and I'm going to label it C. On question 6, I'm given the maximum temperature and the minimum temperature for 6 days in January, and that's shown in the table here. I'm asked to write down the lowest temperature, so that's obviously going to come from the minimum temperature row. I'm going to look along this row, and I can see that -5 degrees C is the minimum temperature. I'm then asked in part B to work out the difference between the maximum temperature on Wednesday, so Wednesday's maximum temperature, and the minimum temperature on Wednesday, -4. So I'm going to draw myself a little number line, -4 and 2, and mark on in between those two must be 0, and then I'm going to work out in 2 steps how to get from -4 to 2. Well, I can see from -4 to 0 would be 4, and then from 0 to 2 I would be adding on another 2. So the 4 and the 2 together equal my answer of 6. In part C, I'm told that the minimum temperature on Sunday, which isn't shown in the table, so I could, if I wanted to, add an extra column onto for Sunday, the minimum temperature on Sunday was 5 degrees higher than the minimum temperature on Saturday. So the minimum temperature on Saturday is -2. So in a number line, -2, and I need to go 5 degrees higher. So 1, 2, that would take me up to 0, 3, 4, 5. And all I've got to do now is figure out what this number is here. So -2, -1, 0, 1, 2, 3. So the temperature on Sunday was 3 degrees C. On question 7, I'm shown some combinations from a menu of a starter and a main course, and I'm asked to write down all the possible combinations that Margaret can choose. So she needs to choose a starter, and then she needs to choose a main course. So I'm going to start with first starter of pate, and she's going to choose beef, and then she's going to have pate and salmon, and then she's going to have pate and lasagna. and I'm going to abbreviate that to pate and beef, and pate and salmon, and then pate and lasagna. Now after that, there's obviously the options where they've had melon as a starter. And similarly, again, melon has 3 options. So I'm going to have melon and beef, melon and salmon, and melon and lasagna. And the third option for a starter would be ham. And obviously for ham I can eat main courses as well. So ham and beef, ham and salmon, ham and lasagna. In question 8, Harry has asked each student in his class how they travelled to school that day, and he's drawn a pie chart with those results. And in part A, I'm simply asked how did most of the students travel to school. So I'm looking for the biggest sector on my pie chart. So the biggest sector on my pie chart, I can see from just looking at it, is walk. In part B, I'm told he asked a total of 24 students, so the pie chart represents 24 students. I'm told that here. And I'm asked to work out the number of students who cycled to school. Well, cycled is up here, and I can see just by looking at it that that is 1/4 of my circle, or 90 degrees. So I've got 1/4 of the students cycled to school, and there was 1/4 of 24 students in total. So to find 1/4 of 24, I'm going to do 24 divided by 4, which is going to tell me my answer of 6. So 6 students cycled to school. On question 9, I'm asked in part A to draw an isosceles triangle. And an isosceles triangle, quick sketch, has this side and this side the same length, and these 2 angles the same side. And it has one line of symmetry down the middle. So as long as I can draw a horizontal line that I can easily go halfway across, I can then just put this point anywhere. So I'm going to draw a line at the bottom and make sure it's an even number of squares. So I'm going to go for 6 squares. So 6 squares from one side to the other, and therefore halfway across will be here. So as long as I put my third and final point for my triangle anywhere on that line, I'm going to get an isosceles one. So I'm going to go up there. And it's a case of joining that point to the 2 ends of my line. And that's an isosceles triangle with this side and that side the same length. In part B, I'm asked to draw a rectangle with an area of 12 centimeters squared. So I'm going to draw a rectangle, could be any size, that has 12 squares on the inside. So I'm going to go 3 squares down, and then I'm going to go 4 squares across. Now obviously it doesn't have to be this size. However, once I've drawn my rectangle, I'm going to check that inside I have got 12 squares. And again, it does say on the grid, make sure your corners of the rectangle are on the grid. On question 10, I'm shown a fair 4-sided spinner. You can see the numbers here go from 1 to 4. And I'm told that Simon is going to spin the spinner once, and it will land on one of those 4 numbers. And I'm asked to mark on the probability scale the chance that it will land on the number 6. Now there obviously isn't a number 6 there, so there is a 0 chance of that happening. Part B, I'm asked to mark on the probability scale with a letter B the probability that the spinner will land on the number 3. Well, I've got 4 options here, and therefore the probability of the number 3 coming up would be 1 out of 4. So I need to go 1/4 away along this line, and that would be there, and I'm going to mark a letter B on there. On question 11, I'm asked to write down the value of the square root of 81, and the square root of 81 is 9. Worth remembering for this question that the square root of 81 could actually be either 9 or -9. 2 possible answers there, but they've only asked me for 1. And the reason for it being either of those is that the square root is a number that times by itself will give you this value. I could do 9 times by 9, which will get me 81. But I could also do -9 times by -9, and that would also get me 81. In part B, I'm asked to work out the value of 5 squared, which is 5 times 5, which is 25. And I want to add on to that 2 cubed. 2 cubed is 2 times by 2 times by 2. Well, 2 times by 2 is 4, and then 4 times by another 2 would be 8. And all I'm going to do is take these two numbers, 25 and 8, and I'm told to add them up. So 25 add 8 would be 33. So my answer there is 33. In question 12, I'm told that Amy has some toy bricks, and that each brick is a cube of side 1 cm, and I'm shown that here. So that would have a volume of 1 cm cubed. I'm told that she uses some of the bricks to make a solid shape. And I'm asked to work out how many more bricks does Amy need to add to make a solid cube of side 3 cm. So a solid cube of side 3 cm would have a volume of 3 times by 3 times by 3, which is 27 centimeters cubed. Now at the moment this shape has in it 1, 2, 3, 4, 5 cubes that I can see there, and then in this column here it's got another 2, so it has actually got 6 and 7 in there, one under the one I can't see. So at the moment I've got 7 centimeters cubed. So the difference between 27 and 7 is how many more I need to add, and that would be 20 bricks that she needs to add. I'm then told that Naveed uses some of the bricks to make this solid shape, and I'm asked to draw the view of it from the arrow that's marked here. So for these questions I always like to draw on the bits that I would see, which is these squares. So from the front I would see 1, 2, 3 in a line. Those in a row. And then above the furthest right one I would see another square. And above the furthest left one I would see another square. And in the middle there is a gap. And that would be my 5 squares that I can see. Question 13, I'm given part of a train time. In question 13, I'm given part of a train timetable from Birmingham to Leicester. And I'm told in part A1 that a train leaves Birmingham at 6:53, so that would be this train here. And I'm asked at what time this train should get to Hinckley, and Hinckley is here. So the train will get in at 0729. In part 2 of A, I'm told how many minutes should this train take to get to Hinckley. So I need to work out the difference between 6:53 and 7:29. So I'm going to draw a number line and go from 6:53 to 7 o'clock, and then from 7 o'clock to 7:29. So from 6:53 to 7 would be 7 minutes, and then from 7 o'clock to 7:29 will be a further 29 minutes. So in total I've gone 7 at 29 minutes. And 7 at 29 is 36, so the train takes 36 minutes to get to Hinckley. In part B, I'm told that Sylvia wants to catch a train at Nuneaton. This is Nuneaton here. And she needs to get to Leicester before 8:30, so this is Leicester here. So I'm going to look along the trains at Leicester and see which one gets there before 8:30. Well, this one doesn't, which means she can't have got on this one at Nuneaton. And this one does. And then obviously any trains in this direction would also get there before 8:30. Now in part B I'm just said what's the latest train that she can catch from Nuneaton. So at Leicester it would be 8:17, so at Nuneaton it would be 0751. In part C I'm told that a train leaves Leicester at 7:27 for Stansted and takes 2 hours and 28 minutes to arrive. And I'm just asked to work out the time. So again I'm going to draw myself a line and start at 7:27, and I need to go 2 hours and 28 minutes forward. So first off I'm going to move forward 28 minutes. So I need to do 7:27 add 28 minutes. Now if I'm not sure, I'm going to take 27 minutes and 28 minutes and I'm going to add them up, and that's going to give me 15, and then 2 and 2 and 1 is 5, so that's going to be 7:55. I've now got to add on the 2 hours, so I'm going to add on the 2 hours. So 2 hours after 7:55 will be 9:55. So the train is going to arrive at Stansted at 9:55. Question 14, I'm shown a diagram of a rectangle and a square, and I'm told that the perimeter of the rectangle is the same as the perimeter of the square. And I'm asked to work out the length of one side of the square. So first off, I'm going to work out the perimeter of the rectangle. Now if this is 8 centimeters, then that must be 8 centimeters, and if this is 2 centimeters here, this must also be 2 centimeters. So the perimeter of the rectangle is going to be 2 centimeters plus 8 centimeters plus 2 centimeters plus 8 centimeters. And that's going to give me 20 centimeters. Now I'm told that the perimeter of the square is the same, so the perimeter of the square must be 20 centimeters as well. Now I know that there are 4 sides to a square, and that each of them is the same distance. So if I take my 20 centimeters and divide it by 4, I'm going to work out that each side is 5 centimeters, and that's my answer for the length of each side of the square. Now if you want to check, you can of course write down 5 centimeters, 5 centimeters all the way around, and just confirm that those 4 do add up to 20, and they do. On question 15, we're shown the minimum distance and the maximum distance people should sit from different size TV screens. And the table is in 3 parts. The first column is the TV screen size, the second column is the minimum distance, and the third column is the maximum distance. And in part A, I'm told that James has a TV with a screen size of 32 inches, which is here, and I'm asked what the minimum distance James should sit from the screen. And the minimum distance, therefore, from the screen is this here, which would be 4 feet. In part B, I'm told that Shiraz has a TV with a screen size of 38 inches, and he's going to watch his TV, and I'm asked to work out the difference between the minimum distance of 4.75 and the maximum distance of 9.5. So, a couple of ways of doing this. The first one is I'm going to use a number line, so 4.75 to 9.5. And I'm going to work my way from 4.75 to 9.5. So I'm going to go first of all to 5, and then I'm going to go from 5 to 9.5. So I'm going to do it in 2 steps. The first stage will be adding on 0.25 to get to 5, and the second one will be adding on 4.5. So in total I've got 4.5 and 0.25, and I can add them up. Put a 0 in there, so 0 and 5 is 5, 5 and 2 is 7, decimal point, 4 and 0 is 4. So my minimum distance to the maximum distance is 4.75 feet. Now if you like, you could do this as a subtraction and do 9.5, take away 4.75, but this is actually quite a difficult subtraction to do. First I need to put a 0 in here, and I can't do 0 take away 5, so I'm going to borrow from the 5, make that a 4, and carry that to make a 10. 10 take away 5 is 5, 4 take away 7 I can't do, so I'm going to borrow from the 9, make that an 8 and call this 14. 14 take 7 is 7, decimal point, 8 take 4 is 4. Same answer, slightly more complicated to do as the subtraction. Always worth checking at the end when you've done a subtraction, that if I take 4.75 and add that on to my original distance of 4.75, I should get to the 9.5. So 5 add 5 is 10, 7 add 7 is 14, add the 1 is 15. 4, 4 and 1 comes together to give me 9, so 9.5, which is what I'm after. In part C of the same question, I'm asked to use the rule given to work out the maximum distance to sit from a TV screen. And the maximum distance in feet is the screen size in inches divided by 4. And I'm told that Claire has a TV with a screen size of 24 inches. So I need to work out the maximum distance. So the maximum distance is going to be the screen size of 24 divided by 4. And 24 divided by 4 is 6, so she can sit 6 feet. Part D, I'm told that Richard should sit a maximum distance of 12 feet from his screen, and I'm asked to work out the screen size of Richard's TV. So again, I've got the maximum distance, and that will be the screen size divided by 4. But this time I'm given the maximum distance of 12. I don't know the screen size, I'm going to call that S, and I'm told that I need to divide that by 4. So to work out S, I'm going to multiply this side by 4, and multiply this side by 4. So S divided by 4 and then times by 4 would just leave me with S, which is what I want, the screen size, and 12 times by 4 is going to give me 48. So the screen is 48 inches. On question 16, I've shown a quadrilateral that's been drawn on the grid, and I'm asked to write down the mathematical name of this quadrilateral. Now it has one pair of parallel sides, and these sides here are the same length. So this shape is called an isosceles trapezium. Part B, I'm shown the same quadrilateral, and I'm told to tessellate, and tessellate means tile, without any gaps between the shapes. So I'm told to draw at least 6, so when I'm finished there should be 7 shapes on my grid. So the first thing I'm going to do is I'm going to trace this shape. And I'm going to try and see how I can get this shape to fit and not leave any gaps. So if I just moved it along, I can see that I'm going to have a triangle in here, which is no good to me. I'm not going to be able to fit the same quadrilateral in there without then creating a problem with an overlap up here. So that's not going to work. So I need to be thinking, if I can't just slide it, I might want to flip it upside down. And if I flip it upside down, I can see that it will fit on there. So I'm going to flip the shape upside down to draw that, and then I'm going to repeat the process and then straighten it back round again. So if I draw that on the grid, that's 1, it's worthwhile numbering them, and then 2, and then 3, and 4. Now I do need to draw 6 shapes, and I'm going to have to figure out, I need to then draw another row of that underneath, and it won't matter how we do this. Again, I'm just going to repeat that row. It's 5 and 6. Odd question 17, I'm told that Debbie, Salma and Wendy did a maths test, and I'm told that the total for the test was 40 marks. I'm also told in the first part of the question that Debbie got 16 marks. So Debbie, 16 out of 40, and I'm going to express that as a fraction. I'm then told that Salma got 35% of the 40 marks. So Salma got 35% of 40. What I need to do is work out what that is. So the first thing I'm going to do is I'm going to find out what 10% is. So 10% of 40, well, to find 10% of anything, I need to take my amount and divide it by 10, as that will split it into 10 equal groups. So 40 divided by 10 is 4. So this represents my 10%. Now if I want 30% of 40, well, 30% is going to be 3 lots of 10%. So I'm going to take this 4 and I'm going to multiply that by 3, and that will get me what 30% is. So 4 times by 3 is equal to 12. So this value here represents my 30%. Okay, in the question I need 35%, so now I need to work out 5%. Well, if I've got 10%, I can find 5% of 40 by halving my 10%. So going in this direction, I can divide by 2 and that will get me 5%. So I'm going to take this 4 and I'm dividing that by 2. So 5% of 40 will be 4 divided by 2, which is 2. And that represents my 5%. So if I want 35% of 40, I can take my 30%, which was 12, and my 5%, which was 2, and add them together to get 14. So in this instance, Salma got 14 out of 40 marks. I'm going to write that again as a fraction here as 14 out of 40. That's this part of the question taken care of. I'm then told that Wendy got 3/8 of the marks. So Wendy got 3/8 of 40. So again, I need to find 3/8 of 40. So the first thing I'm going to do is I'm going to find 1/8 of 40. Or to find an eighth of something, I'm going to divide it into 8 separate parts. So 40 divided into 8 separate parts would be 40 divided by 8, which is 5. Now I don't want 1/8, I want 3/8. So 3/8 of 40. Well, if I've got 1/8 and I want 3/8, I want 3 separate lots of 1/8. So I'm going to want 3 lots of my 5. So I'm going to do 5 times by 3, and I'm going to get 15. So 3/8 of 40 would be 15. And again, I'm going to write that as a fraction. That would be 15 out of 40. So I've now got my 3 fractions. I've got Debbie got 16 out of 40, I've got Salma got 14 out of 40, and Wendy got 15 out of 40. So I can see from this that Debbie got the highest mark, which is what I'm asked here in the question. So I need to write down my answer. Debbie got the highest mark. On question 18, I'm told that Bill uses his van to deliver parcels, and that for each parcel Bill delivers there is a fixed charge plus £1 for each mile. And that information is shown in the graph here. And in part A, I'm asked how much is the fixed charge. So the fixed charge is a cost you incur when you have travelled a distance of 0 miles. So if I come to my horizontal axis, which shows me the distance and 0, I can draw a line up until I hit the graph, and that tells me that the cost would be £10. In part B, I'm told that Ed uses a van to deliver parcels, and that for each parcel Ed delivers, it costs £1.50 for each mile, and that there is no fixed charge. And I'm asked to compare the cost of having a parcel delivered by Bill with the cost of having it delivered by Ed. So the first thing I'm going to do is try and turn the information here for Ed into a line that I can draw on my graph. So I know that for 0 miles for Ed, it costs no pounds, as there is no fixed charge. And therefore for 10 miles, if I use the information given here, that will be 10 lots of £1.50, which is £15. And I'm going to plot both of those pieces of information on my graph. So 0 miles and £0 is here, and 10 miles and £15 would be 10 miles up to 15 there. Now both of those points are very close together. So what I'm going to try and do is work out another point that's further away to make my line more accurate. So on my distance axis, I can see that 50 is the maximum distance. So I'm going to work out the cost for 50 miles. Well, 50 miles is 5 lots of 10 miles. So I'm going to do 5 lots of 15 to work out how much it would cost for 50 miles. So £15 times by 5 is £75. And now I'm going to plot that point on my graph. So 50 miles, £75. 50 miles up to £75, which is there. And now I'm going to join those points up with a ruler. Now because the points are further apart, the line's now more accurate. Okay, so I've now got the cost of Ed, and here I've got the cost of Bill, and I'm asked to compare them. Well, I can see from my graph that the lines cross at 20 miles. So at 20 miles, it costs £30 for both Ed and Bill to deliver. So I'm going to write a sentence here that says that it costs the same for both Bill and Ed at 20 miles. And now what I need to do is make some comment about what would happen before and after 20 miles. So after 20 miles, I can see that for Bill, I'm going to have a cost of £40. And for Ed at 30 miles, similarly, going up until I meet the line, his cost is going to be somewhere in the region of £45. So Ed is more expensive after 20 miles. And now I need to do a comparison for less than 20 miles. So first off, Ed, at 10 miles, Ed would cost £15. And at 10 miles, Bill cost 20 miles. So Ed is cheaper at 10 miles. So Ed is cheaper before 20 miles. On question 19, I'm told that a pack of 9 toilet rolls costs £4.23 here, and I'm also told that a pack of 4 toilet rolls costs £1.96, and I'm asked to find the best value for money. So to do that, I'm going to try and make sure that I've got the same amount of toilet rolls for the pack of 9 as for the pack of 4. So I'm going to write out, if I had 9, and then another pack of 9, I'd have 18, and then another pack of 9, I'd have 27, and then 36, and then 45, and so on. I might need a few more, we'll see in a minute. Similarly, for the pack of 4, I'd need 4, and then 8, and then 12, 16, and I'm going to keep going, 20, 24, 28, 32, 36. And I can see that the number 36 appears in both of those times tables, and that's the lowest common multiple. An LCM. So the lowest common multiple is 36. So if I can make sure I've got 36 here and 36 here, I'll be able to compare the prices. So for the pack of 9, I'm going to need 1 lot, 2 lots, 3 lots, 4 lots. So I'm going to need 4 lots of this. And for the pack of 4, I'm going to need 1, 2, 3, 4, 5, 6, 7, 8, 9. So I'm going to need 9 lots here. So I'm going to need to do £4.23 times by 4. And I'm also going to need to do £1.96 times by 9. Now, however you multiply these, you might want to use £4.23 multiplied by 4, so 3 4s are 12. 4 times by 2 is 8, so a 0 and then an 8, and 4 times by 4 is 16. And then add up, work my way around from here, so I've got 2, 1 and 8 is 9, 0 and 6 is 6, and 1 here on its own. And then I'm going to try and put the decimal point in the right place. Well, this decimal point and this decimal point would come down until they met here, and therefore I'd end up with 16.92. So that would be £16.92. And again, I can go through the same process for £1.96 times by 9. So £1.96 times by 9. And then again, 6 9s are 54, 9 9s are 81, and 1 9 is 9. And again, adding my way around from here, 4, 5 and 1 is 6, 9 and 8 is 17, carry the 1, 1 and 0 is 1. Same again with the decimal points, until they meet. Therefore I'm going to be left with £17.64. And I can see for that the pack of toilet rolls that's the cheapest is the one costing £16.92 for 36. And that was when I did 4 lots of £4.23. And therefore the pack of 9 is the cheapest. Now, I can also do this a slightly different way. And we'll do that down here. I could work out the price for one toilet roll in each situation. So for the pack of 9, I need to do £4.23 divided by 9. And to do that, I would use the bus stop. So 9s into 4 doesn't go, so I'm going to carry the 4, put my decimal point in. 9s into 42 is 4 remainder 6, and 9s into 63 is 7. So one toilet roll costs 47 pence. And similarly for the pack of 4, I need to do £1.96 divided by 4. And again with the bus stop, 4s into 1 doesn't go, carry the 1, decimal point, 4s into 19 is 4 remainder 3, and 4 into 36 is 9, so 49 pence there for a single toilet roll. Same answer either way, pack of 9 is the better value. In question 20, I'm given a stem and leaf diagram showing some information about the speeds of 25 cars, and I'm given the key here. In part A, I'm told that some of the cars had speeds of more than 50 miles per hour, and I'm asked to find out how many of the 25. Well, I'm looking for the speeds more than 50, so this here represents 50, so anything past 50 will need to go in here. So 1, 2, 3, 4, 5, 6. So there are 6 cars with a speed of more than 50 miles per hour. I'm then asked to find the median speed, and to do that I'm going to have to find the middle number because the median is the middle. Okay, so I know that there are 25 cars, so I'm going to work my way in, one from the smallest end and one from the largest end, until I get to the car in the middle. So smallest, largest, smallest, largest, smallest, largest, smallest, and then the largest, smallest, and then the largest, smallest, and then the largest. And I'm going to keep this going until I'm left with one number in the middle there, which is the 4. But it's important I realise this is in the stem, also a 4, so the median speed is 44 miles per hour, not 4. I can see from the diagram that the smallest speed is 29 miles per hour, so it couldn't possibly be 4 miles per hour as the median. Part C, I'm asked to work out the range of the speeds, and the range is the biggest speed. Take away the smallest, and the biggest speed is shown here by this, and the smallest speed is shown here by this 9. So the biggest speed is 60, and the smallest speed is 29. 60 take away 29 is 31. In question 21, I'm shown a diagram, and I'm told that ABC is a straight line. Now I can see that from the diagram, so I'm not going to worry about that too much. I'm told that BD is equal to CD, and that's BD there, and that's CD, and they've marked it at the same length by putting those dashes on. I'm also told that angle BDC is 50, so BDC is 50, and that's marked on the diagram, so I don't need to worry about that. And angle ADB is 20, and again it's marked on the diagram, so I don't need to worry about that. And I'm asked to work out the size of the angle marked X. The angle marked X is down here in this corner. So the first thing I'm going to do is I'm going to consider the triangle DBC, and I'll draw it out here. So there's D, and there's B and C, and those lengths are the same. I'm told that this is 50. Well, I can see from that that this is a triangle, so there must be 180 degrees in it. And I also know that these two angles down here, because it's an isosceles triangle, because these are the same length, must be the same. So if I can do 180, take away 50, that's going to be 130. And then if I can take 130 and divide it by 2, I'm going to get that is 65. And again, if you're not sure, you can do the bus stop. 2's into 1 doesn't go. 2's into 13 goes 6, remainder 1, and 2's into 10 goes 5. So I know that each of these angles is 65 degrees. I'm going to write that on the diagram at the top. Now in the question it does ask me to give reasons for my answer, so I'm going to write down that triangle BDC is isosceles. Once I know this is an angle of 65 degrees, I'm going to try and use that to work out some of the later angles. So this time I'm going to draw the line A to C, and I'm going to mark on the point B and draw on the angle that I've just worked out here, that B, which is 65 degrees. Now from that I should be able to work out what this angle is here. Now I'm going to write angle ABD equals, well, there's 180 degrees on a straight line, so 180 takes 65 is going to be 115 degrees. And that's because, again, given a reason, there are 180 degrees on a straight line. Okay, and again I'm going to mark that on my diagram at the top, so I've now marked that on as 115 15. So finally, I've now got enough information to work out the angle at A called X. I'm going to draw that triangle, where I've got 115 here. This angle in here is 20, and this is the angle X in there. And that's D, and there's B, and there's A. And again, it's a simple case of adding up what I've got, 115, add 20, which is 135, and then doing 180, take away 135, which would be 45 degrees. So X equals 45 degrees. And again, if I wanted to give a reason for that, I would write down that there are 180 degrees in a triangle. On question 22, I'm shown a diagram of a patio that's 3.6 meters by 3 meters, and I'm told that it's going to be covered with paving slabs that are each 60 centimeters long and wide, as they are squares. I'm told that Matthew buys 32 of the paving slabs, and I'm asked if he'll have enough to cover up the patio. So what I'm going to do is I'm going to draw the diagram a little bit larger down here. And I've got 3.6 meters here. Well, I know that 3.6 meters is the same as 360 centimeters. And I've done that by timesing that distance by 100, as there are 100 centimeters in a meter. I also know that 3 meters would be 300 centimeters. And again, 100 centimeters in 1 meter, so I've times it by 100. Now, if each of the slabs is 60 centimeters, it's a case of figuring out how many would fit along and how many would fit up. So 60 centimeters going up to 300. Well, after 1, it will be 60, then 120, then 180, then 240, and then I would have 300. So what I've done there is I've done the 60 times table. So 60, 120, 180, 240, and then 300. So I'm going to fit 5 slabs, 1, 2, 3, 4, 5 slabs going up. Now, by the same logic, I'm going to try and see how many slabs I can fit along, given that I know that it's 360 across. So I'm going to fit 1, 60, 2 for 120, 3 for 180, 240, 300, and 360. And again, that's from my times tables. I've gone 60, 120, 180, 240, 300, and then 360. So I've got 1, 2, 3, 4, 5, 6 slabs across. So in total, I'm going to have 5 rows and 6 columns. So I'm going to have 5 times by 6, which is 30. So I'm going to need 30 paving slabs to cover this, and I'm told that Matthew buys 32. So does he have enough slabs? The answer is yes, in part A. In part B, I'm told that the slabs cost £8.63 each, and that he buys 32 of them. So I need to do £8.63 times by 32. So a couple of ways of multiplying numbers like this. I could use this grid, where I've got 8.63 times by 32, and then multiply each box out. So 3 times by 3 is 9, so 0, 10, 9 units. 3 6s are 18, 3 8s are 24, and then the next row, 3 times by 2 is 6, so 0, 10s and 6. 2 times by 6 for this box will be 12, so 1, 10, 2 units, and for this box, 8 times by 2, which would be 16. And then again add up as I go around, so 6, 9, add 0, add 2 is 11, so 1, carry the 1. 0 and 8 is 8, add 1 is 9, add 6 is 15, add 1 is 6. 15, so 6, carry the 1. 1 and 4 is 5, add 1 is 6, and another 1 is 7, and finally the 2 there. And then it's a case of figuring out where the decimal point goes. Well, 32 has a decimal point after the units there, and I've got my original decimal point there. So they would come down until they met, and they would meet just here, and therefore I'm going to have £276.16. So my answer is £276.16. Now, some people might prefer to turn this into pence and do it as 863 multiplied by 32 and draw a slightly different grid. So for this box, 2 times by 3 is 6. For this one, we've got 2 times by 60, so 2 6s is 12. Add the 0 back on. For this box, I've got 8 times by 2 is 16. And add the 2 zeros back on. And similarly for here, I've got 3 times by 30, which would be 90. And then 6 times by 3 would be 18. And then I'm going to add both these zeros back on to get 1,800. And then here I've got 3 times by 8 is 24. And then I've got 1, 2, 3 zeros. So 24,000. And then it's a matter of adding those numbers up, and I'm probably going to run out of space. So 24,000, 1,600, 1,800, 120, 90, and 6. And if you add those up, I'm going to get the same answer as I get here, except I won't have a decimal point. I'll have 27,616. And as I'm asked for it in pounds, I'll need to remember to put that decimal point back in. On question 23, I'm given the ingredients needed to make 12 shortcakes. So I need 50 grams of sugar, 200 grams of butter, 200 grams of flour, and 10 millilitres of milk. And I'm told that Liz makes some shortcakes, and she uses 25 millilitres of milk. So rather than using 10 millilitres, she uses 25 millilitres. So 20 millilitres and 5 millilitres would give me 25 millilitres. So if she's using 20 millilitres of milk, she must have made double the amount of shortcake, so she would have made 24. And if she's used 5 millilitres of milk, she would have made half the amount of shortcake, so she would have made 6. So in total, she must have made 24 add 6. So she's going to have made 24 add 6, which is 30 shortcakes. Now obviously there is a different way of doing this. We could have said that 25 millilitres divided by 10 millilitres equals 2.5, and therefore that 12 times by 2.5 equals 30. But I think it's easier to understand it in terms of halving and doubling the original recipe. In part B, I'm told that Robert's got 500 grams of sugar, 1,000 grams of butter, 1,000 grams of flour, and 500 millilitres of milk. And I'm asked to work out the greatest number of shortcakes that he can make. So 50 grams of sugar and 500 grams of sugar. So what I'm going to do is I'm going to do 500 grams of sugar divided by 50, and I'm going to get 10. So here we can make 10 lots of those 12 shortcakes based on the sugar. Similarly for the butter, he's got 1,000, and it takes 200 grams to make each set of 12. So 1,000 divided by 200 is 5. So we can only make 5 lots based on the sugar. And again for the flour, it's 1,000, and again it's 200 grams. 12, so 1,000 divided by 200 is 5. So based on the flour, he can only make 5 sets. And finally for the milk, it's 500, and he requires 10 millilitres for every batch of 12. So 500 divided by 10 is 50. So he can actually make 50 sets based on the milk. So the greatest number of shortcakes he can make, well, he's going to run out when he runs out of butter here and flour here. So the actual maximum amount he can make is 5 groups, and each set will have 12 in it, so he can actually make 60 shortcakes. In question 24, I'm told that buses to Acton leave the station every 24 minutes, and that buses to Barton leave the station every 20 minutes. And I'm asked to work out the time that both buses will leave the bus station at the same time, given that they start at 9 o'clock. Well, the first thing I'm going to do is I'm going to continue these on. By doing my times tables, and again for the 20s, 40, 60, and I can see that the number 120 appears in both of those lists, and that's the lowest common multiple. So the lowest common multiple in this case is 120 minutes. Now 120 minutes is the same as 2 hours, given that there are 60 minutes in an hour, and therefore it's going to be 2 hours before the buses leave the station again at the same time. Now they both left at 9 AM, and I'm adding on the 2 hours, so 9 add 2 is 11. So the next time that they're going to leave at the same time is going to be 11 AM. On question 25A, I'm asked to expand 3 lots of 2y, take away 5. So 3 lots of 2y is 6y, and 3 lots of take away 5 will be the same as taking away 15. So I can do it with the box method here, or I can actually just write out 2y take away 5 3 times. Either way, I get 6y take away 15. In part B, I'm asked to factorise 8x squared plus 4xy. Now, a couple of ways of doing this. What I'm going to do is I'm going to find the highest common factor of 8 and 4. So the highest common factor of 8 and 4 is 4. 4 will divide into 8 twice, and 4 will divide into 4 once. And I'm going to rewrite this sum as, instead of 8, I'm going to have 2 times 4 to give me the 8, and instead of x squared, I'm going to have times x times x. And I'm adding on to that. Instead of 4, I'm going to use my highest common factor and have 1 times 4 times by x times by y. And it is important that I have this 1 in here because I need to do a multiplication to get the 4. So 1 times 4 gives me 4. I'm then going to find the common factors. So I've got a 4 in this first term, and I've got a 4 in the second term, so that can go at the front of my brackets. I've also got an x in both terms, so I've got an x in both terms, and I haven't got any other factors that are the same in both the first term of 8x squared and the second term of 4xy. So what I'm left with is 2x add 1y, and 1y I can obviously just write as y. So inside my brackets I'm going to have 2x plus y. In part C, I'm asked to make h the subject to the formula, and I'm showing what that means down here. It means I should end up with h equals. So the first thing I don't like that I'm going to get rid of to try and get h on its own is this divide by 10. So I'm going to times both sides by 10. And if I times both sides by 10, I'm going to get 10 times t is 10t. And 10 times by this is just going to leave me with gh. Now I know that gh is g times h, so I'm going to get rid of the times g by dividing by g. And if I divide this side by g, I'm just going to be left with h, which is what I want. And if I divide this side by g, I'm going to get 10t divided by g. So I'm going to write 10t divided by g. On question 26a, I'm shown a medicine bottle that has 300 millilitres in it. And I'm told you have to take 2 5mm spoonfuls twice a day. And I'm told that Mary has to take the medicine until the bottle is empty. And I'm asked how many days does it take for the bottle to empty. So first off, 2 5mm spoonfuls. Well, 2 5mm spoonfuls would be 10 millilitres. I'm also told that that has to happen twice a day, so twice 10 millilitres would be 10 times by 2, which would be 20 millilitres. So she takes 20 millilitres each day. Now, there are 300 millilitres in the bottle, so if I do 300 divided by 20 millilitres, which is how much she takes each day, and 300 divided by 20 would be, well, I'm going to take a 0 off both those numbers, and I'm going to have 30 divided by 2, and I'm going to get 15. So it's going to take 15 days until the bottle is empty. In part B, I'm told you can work out the amount of medicine C to give to a child by using the formula, which is C equals M times by A divided by 150. And then I'm told that M is the age of the child in months and that A is an adult dose. and then I'm given that a child is 30 months old, and therefore M equals 30. And I'm also told that an adult's dose is 40 millilitres, or in other words, A equals 40. And then I'm asked to work out the amount of medicine you can give to the child. So I'm going to take these numbers of M is 30 and A is 40, and I'm going to put them into this formula. So C equals M, 30, times by A, which is 40. It takes care of the MA, and then I need to divide that by 150, which I could write as divide 150, or if I kept it the same as above, I would be writing as 30 times 40 over 150. Well, 30 times 40 is 3 times by 4, which is 12. And then 0 and 0 to add back on, so I've got 1,200. And I need to divide that by 150. So I'm going to cancel power of 10 on both the top and the bottom, and I'm left with 120 divided by 15. Now, if you're not sure, you can write out your 15 times table. 15, 30, 45, 60, 75, 90, 105, 120. And from that I can see that there is 1, 2, 3, 4, 5, 6, 7, 8 15s in 120. So the amount of medicine to give is 8 millilitres. On question 27, I'm shown a parallelogram. This side is parallel to this side, and this side is parallel to this side. And I'm shown the size of the angles in degrees, and they're given in terms of x. So 2x here and 2x here, these two angles are the same size, and 3x take away 15, and 2x plus 24 here. And I'm asked to work out the value of x. Now I'm dealing with angles, so I need to remember what the sum of the angles in a quadrilateral is, and I know that that is 360 degrees. So if I add up all of these angles, I should get an answer of 360 degrees. So I'm going to add up all those angles. So I've got 2x, add 2x for these two angles, and then I've got 3x, take away 15, and I've got 2x, add 24. And I'm going to add them up. So 2x, 4x, 7x, 9x, take away 15, add 24. And that's the same as adding 9. So I know that 9x, add 9, is the sum of the angles in terms of x, and I know that that has to come to 360 degrees. And I've now got an equation that I need to solve. So the first thing I'll do is I'm going to get rid of this add 9 by taking away 9 from both sides, and that will get me that 9x is equal to 351. Now I know that 9x is 9 times by x, so if I want x on its own to give me the value for x, I'm going to have to get rid of this 9 times. To do that, I'm going to do the opposite of times 9, which is divide 9. So I need to do x will be 351 divided by 9. So again, bus stop. 9's into 3 doesn't go. 9's into 35 goes 3 times, remainder 8. And 9's into 81 goes 9 times. So x is 39. And that concludes the exam paper.